Thanks for the introductions, and really delighted for two reasons. We heard about cows. Next to cow, you need to think about potatoes, because milk and potatoes is all you need to survive in this world as a human. So really glad to fly the flag for potatoes. And secondly, I've been a chartered mechanical engineer myself for more than a decade, and this is my first time. And I always get excited when I see a bunch of people whom I've never met, because that's all it's all about collaboration, except you, Robert. I think there's one person I know in this room, which is always glad to see. But this is all about collaboration. I'm very keen to see how this presentation, this topic converts into and transfers into collaborative talks after this slide deck. I have multiple hats within various companies. There is a direct correlation between that and my loss of hair. But if you keep that aside, I'm going to cover more about Branston and B-hive Innovations. Branston, if you're thinking pickles, it's not the right company. The clue's in the potatoes. We're the largest potato packers in the UK. And if you're buying potatoes from Tesco, 100% of those comes from Branston. It's a company based in Lincoln, and we got 3 sites. We have roughly about 900 colleagues. We handle about 350,000 tons of potatoes a year. That's quite a lot of potatoes, simply put. We also do sweet potatoes. If you can't compete, collaborate. So Branston covers the entire supply chain. So anything from bringing new varieties to actually supplying and marketing the crops with major retailer such as Tesco. So Branston's a 100% potato supplier into Tesco. So they're what Tesco would call a product partner. Potatoes are simple, I thought, when I joined 18 years ago, but it's very complex. The term variability Kit mentioned keeps coming to me again and again every year. There are 3 major challenges I would like to highlight in the context of what we are going to cover today. The photo on the left you're seeing here of a potato harvester stuck in the field is very current. There's the British Potato Conference. There is a conference for potato people as well in Harrogate yesterday. And it's not a great story. 90% of potatoes in England come out of the ground. If you go to Scotland, there are thereabouts. If you go to Ireland, 40–50% of potatoes that were grown for this year still in the ground because of floods. The point is, the frequency of climate extremities we are seeing quite often. And that's a major problem for agriculture, but also for potatoes. The race to net zero is also increasingly becoming an additional pressure. It's the right thing to do, but the race to net zero is something that we need to think about. The third thing, that's how the potatoes would look like if you don't use chemicals. The chemicals has led us to use crops for longer, both in storage and outside the storage. Today, we are seeing a lot of climate extremities. We want to get the most out of less in a shorter period of time, but we're also starting to ban chemicals that were really tools to increase our productivity. Gentlemen and ladies, these are not complementary objectives. These are conflictory objectives. And that's what the world of potatoes is facing. And that's not starting from an interesting point either. The foundations of potato farming is not 100% precise. It's what Kit and others kind of point out to say that it is not an efficient supply chain to start with. There's a lot of losses. What you plant, if you get 60%, if you use 60% of what you planted utilized, it's a fantastic thing that we've done. But those opportunities are there. The challenges becomes opportunities. So Branston, being Branston, thought the continuous improvement to solve these conflictory objectives is not easy. There needs to be something step change. We need to innovate. We need to invent if we have to break through that cycle. And that's why 7 years ago, we created a company called B-hive Innovations to conduct research and development purely in the view of commercializing those, collaborating with the partners, primary research from universities such as Harper and others, but mainly to solve the problems that therefore Branston can put into their supply base to help farmers grow better. So no surprise, all the challenges is what our purpose is. I'm not going to read it in the interest of the time. But what we do, we essentially take problems, we use the human capital. It's very important nowadays. We are all mesmerized with the artificial intelligence. We do need some human intelligence too, so we shouldn't forget that. And we use most of that, and we create solutions. When we create solutions, if they are commercially viable, we spin off new companies to commercialize it. I think Harvester is the inside camera systems we'll speak about. Root extracts, completely different. We are making potato proteins for plant-based industries from outgrade potatoes. Valorization of the lowest value product and creating new value chain in the much needed potato supply chain. And that's what root extracts does. I'm very technically minded, so is these questions and the challenges. So I'm going to invite Mercedes to explain how we go about solving these challenges. But in the context of today, we've just put 4 challenges on how the technology could solve it, or how we are going about solving it. Should I even bother? Very technical question. If you're a potato farmer, you're thinking, should I even bother farming potatoes? But it's not that. There's quite a lot of pests that's in the field, and potato farming is a rotational crop. So if you farm in that field, you can't come back to the same field for another 6 years. But if you got pests, it's a bit of a problem. And if they are really nasty pests that Mercedes hates, we have a bigger problem. The Holy Grail. What is the Holy Grail in the world of potatoes? Well, potatoes grow under the ground. New fact. However, what if I can see potatoes under the ground whilst it's growing? That could be fantastic, couldn't it? Simple problem to solve. We need returns, pound symbol. Can't get away from that. And we smell a rot. Could we smell a potato? Let's find out. Over to Mercedes.
My name is Vidyanath Torres. So I'm going to cover how B-hive is working in this problem space and presenting solutions across hopefully all 4 of them. So the first question that any grower right now is thinking is, should I even bother putting potatoes in my rotation? I think Keith covered it and V did. There are a lot of regulations that are changing the way potatoes are being grown. And pesticides that you could use 10 years ago suddenly are out of the question. And that means that things like pests can prosper really, really quickly without you noticing. So when it comes to deciding whether or not you're growing potatoes, then the growers need to know if they are willing to take a risk. But could it be possible, through the use of artificial intelligence and computer vision, to actually tell the grower, hey, this is actually the risk that you're running, because we can detect pests, in particular wireworm, the biggest one that they have, in your field as you are, for example, destoning. So you don't make the mistake, or if you know that there are wireworms there, you get to take the risk. Now, there is only one small problem, and is that wireworms are tiny. There is a wireworm in this image. It's actually highlighted and labeled. Anybody wants to take a guess where it is? Yeah, great. So the problem from a technical perspective is that an image with wireworms and an image without wireworms are going to look very, very similar. There's only a few pixels of difference, which is the wireworm itself. So how do you tackle the problem? Well, in artificial intelligence or computer vision, you would do it like in real world. You have a big problem, you break it down. So the idea that we run is, there we go, we window the image. So we develop a vision system that can take images in the field, and then you divide it in very, very small chunks until you treat everybody differently until you find the wireworm. You aggregated all that information back up, you geolocate it, and then you can thankfully end up with a map that tells you the concentration of wireworm that has been detected in that field. You're a grower, then you can decide, well, it's close enough that, oh, I'm not even touching potatoes, or actually, it's not that big of a deal. The important thing as well is that this vision system, which hopefully you can see there, that's the camera, where's the laser? That's the camera, that's the system there, and that's the system, and that's the camera there. This is done as the grower is destoning. So therefore, they have enough time to decide once they get these results to whether or not they want to actually plant potatoes. So let's say after all that you don't have any wireworm, or you want to take the risk and you actually plant potatoes. Then we come to the second stage, or the second problem. And it is that once you plant potatoes, is anybody's guess, right? You can do sample digs, you can do observations, but you don't actually have a full view of a field, complete and comprehensive as the harvest is coming up. So let's say, could we use, again, artificial intelligence and in particular computer vision and digital signal processing to be able to see above ground, below ground, and combine all of that to give a grower a picture of how the crop is moving in time. So the important thing is not only that you're telling them, this is what your crop looks like today, you're also saying, hey, let me project it 1 week, 2 weeks, 3 weeks, and let me tell you when is the right time to burn down so you can maximize your marketable yield, meaning you get the most money out of your field. Now, simple proposition, complicated problem, but the way we divided it was combining artificial intelligence above and below ground. So above ground, not that complicated. You can use things like drones or like autonomous vehicles or rovers to take images of your field and then analyze the plants and the stems. Stems are a little bit more complicated, but they're really useful because there is a relationship between the number of stems a plant will have and the number of tubers under the ground. So we applied computer vision to locate plants, to detect the stems, and to be able, given a region, to tell you the number of stems that you can expect, and therefore the number of tubers that you could expect below ground. This is, however, step 1. Step 2 is the interesting bit, and it's when you go to look under the ground. And the way B-hive went about it is actually through collaboration, so through transfer of knowledge. We started with working with the military. So what you see there is a GPR, a ground-penetrating radar from the military. So they used those to defuse IEDs. And the idea that we had, amongst other people in B-hive, were, can we use that to, I don't care about the IEDs, I care about potatoes. Can I see potatoes under the ground? And turns out for £250,000, you can, but you're not going to get a grower to actually pay £250,000 just to see their potatoes under the ground. So part of the work that we did was to transfer all of that technology, strip it down, and do something portable or create a GPR that is portable and can be put in a tractor. So what you're seeing there is our tractor mount facility that has a GPR that is scanning the ridge. And it's scanning the ridge, it's generating this image. Now, my digital signal processing person said that there are potatoes there, and I trust them. But no, in reality, we have studied that the hyperbolas that you see, particularly places like there, those are responses for potatoes under the ground. So now you have number of stems above ground, number of plants, and then you have mass under the ground. You can combine all of that together to create a model that can tell you what you can see above and below in a field at a particular point in time, and you do that through mathematical models combining all of that information. And here you can see our dashboard in which you can select, and that will tell you in time, so as you're advancing in time, how your marketable yield changes. And the important thing is here at the top is telling you, hey, that is the proportion of your field right now that is under marketable yield. What you want is to find the maximum there, and that's when you burn down. If you wait too long, the marketable yield will fall down because you will go into the oversizes. So this is right now, we got further funding, I can say that, hopefully. No, but anyway, it's advancing, but yeah, our hope is to make a commercial product out of it. All right, so the final, or before we finish, there is something that is really important as well, and it's that you want to give growers an understanding of not only their crop, but how much return they can expect on their crop, right? So that's what we like to call the returns. I don't know if you're aware, but there is a large proportion of measurements that happen right now in the potato industry that only work on digs or small, very small samples. And then you just take a small sample, as you can see somebody there doing, and you extrapolate, extrapolate, extrapolate. And one of the core principles of B-hive and Harvest I has always been, what if you could actually open that pool of samples? What if you could see the whole field? Ideally, what if you would to see the whole field as you're harvesting? You could say to a grower, hey, I've seen what you've passed through the belt in the harvester, I can size it, I can weight it, and I can tell you right now that this is the proportion of marketable yield that you lifted today. This is what you can expect out of this particular field. And that's exactly what Harvest I does. The problem, of course, is that this is what my environments look like. So as a computer scientist, I have to create a system that can actually deal with all of these things. All of these are real, by the way. They all come from actual harvesters in which Harvest-I has been installed. This one gives me a nightmare still. That one should be in jail. So not only you have this problem, this is 1 second, and then we're moving for hours and hours and hours. If anybody wants to guess, the highest number of potatoes that we saw in one single frame in 2022 adds to 600, hopefully that will show, 686. But this is 1 second. Next one, another 600. Next one, another 600. Next one, maybe nothing. Next one, nothing. So it's variable. It's in location, meaning the power that you have is the power that you can have in a field, and you have to detect a lot, measure a lot, and make sure that all of that information gets back to base so a grower can actually engage with it. So pretty tall order. The idea, however, goes back to coming back to the science and how can you actually fix this problem. And the science brings us back to computer vision. So I don't know if anybody here has done any computer vision in the past, but the idea of computer vision is that you want to make a machine understand an image or a video. And this is something that hopefully everybody agrees. Machines are dumb. You need to give them a lot of data and a lot of relevant data for them to understand what it is that you're trying to solve. And if you think about it as a human, you can see that image and you understand it very quickly. You can say, oh, I can see cows. I can see 3 cows. I can see 3 white cows. I can see 3 white cows in the daylight in a field. But a machine will need to be told all of that. And in order to produce those results, you're training it into different problems. So the first idea would have been like, hey, just tell me if there are potatoes or not. Not very useful for the growers. The second idea is to say, hey, there are potatoes. They are roughly around this area. But if what you want is to size and to weight, a bounding box or a rectangle around the potato won't give you the information that you need. There is something else that you can try, which is to trace all of the pixels that are potatoes or not potatoes. But Branston remained uninterested in a big block that just said you have potato pixel. They didn't like that. So we ended up with something that is instant segmentation. So that is the combination of everything that we've talked about. It will detect what you need to detect, but it will also it would also trace it. And from then on, I can extract whatever is of interest to me and use that to size and weight the potatoes. How does that look? Well, that looks a little bit like that. And if you show it enough potatoes, then they'll be able to figure out what's a potato, what's a rock, what's a bar in the middle, what's a hand. So you're able to just say, hey, look at the potatoes that you can measure, and extract from them the size and the weight. All of these are from this year from Harvest-I, by the way. So these are all real scenarios in which we're working. And where it works as well, not only we have cross-pollination with the fence, this little tablet, which is what we use as Harvest-I as our processing unit, comes from gaming. So actually the gaming industry saved us. Thank you, gaming industry. This one didn't exist in 2022, so it was released in January 2022, I believe. So it's really, really, new, but also we couldn't have done this at this level 5 years ago or even 3 years ago because the technology to put it in the harvester wasn't there. All right, I have to finish. Transferable to other crops. Take my word for it. But yeah, we can do it in onions, we can do it in sweet potatoes, and we can do it in apples. And then finally, just to mention what happens once you know what you've lifted, you've stored it, you put it in place, you're going to leave it hanging for a few months. You want to know if that crop that you're going to take out is as good condition as it was when it came in. And that reason is why we want to smell a potato. Or in other words, I think it's common knowledge that dogs can sometimes, for example, smell cancer or smell certain sicknesses in people because we emit certain volatiles. Potatoes and sweet potatoes also emit certain volatiles when they are sick, when they have certain illnesses. So we have developed a sensor system, which you could see in the previous one, something like that, that sits in a cold store and is able to monitor the volatiles as the potatoes are resting. And when they figure out that there is something going on, certain volatiles go really high, then you can start detecting certain rotten crops, such as black heart, and then you can tell the grower exactly, hey, there is a problem in this cold store, you need to figure out what's happening, and you need to take out the crop that is not relevant. Anyway, that's all from now. That's all from me. Thank you very much.